Okay, I believe I'm live. Let me just check everything and check my audios. Welcome. Thank you for joining me this Saturday morning. And let's just make sure the stream started. Okay, let me check my audio. Check my audio. Yep, good. Okay, we are live, and I'm watching the chat. So I've already published this on my socials, and I'm just going to go over some things. First of all, let's take a look at some things before we get started. Okay, so we're going to be using Gemini-CLI today, the Gemini command line interface. And that's exactly what it is. It's a command line interface for the Gemini artificial intelligence, the large language model. You could do this through the GUI, right? If I go to gemini.google.com, but this is the command line interface, all right? It's easy to install. You can follow along. You can actually do this at home if you want. That would be really cool. Hey, good morning, Mike. Thanks for joining. Hey, morning. So I would brew install this on Mac, or you could npm install it in Ubuntu on WSL and Windows, or I suppose homebrew it in Windows and WSL on Linux. That's our foundation, okay? Now, they have extensions now. From October 8th, they made this public. And extensions are exactly like a VS Code extension. And I'll show you as a developer why I like extensions after we get going a little bit. We'll do some packet analysis first, and then I'll come back to the code. We will look at code today. But this is really cool. And they actually have an extensions. You know, they're on this 5.4. Hopefully we don't get any 429 errors today. I'm hoping not. But there is extensions. And if you look in here, I don't think my packet tool is in here yet, but my vision tool is in here. And I don't know if any of my other tools made it yet, but you just install the extension with a one-line command. So I'm going to show you a couple things here on my GitHub first. And what I mean by a one-line command, if you're at home and want to do this and follow along, install Gemini-CLI, add your Google API key to your .env file or export it for Gemini-CLI, right? In .gemini, there's a .env file you can add your keys to. And you just run this one-line command. Gemini extensions install and the location of this repository, and that will install. And don't worry, we're going to look at all this code under the hood. That will install this extension. To show you how long I've been doing this, this is my Packet Buddy repo. And I was curious when I started really doing artificial intelligence with packet captures. And if I look at the history of my README, the initial commit was February 13th, 2024. And what are we right now? We're November 1st, 2025. So this is a long journey for me to get from Packet Buddy as a standalone Olama Streamlit app, which I still love, and people do love. It actually has a lot of stars and forks and everything. And then I've got a bunch of questions staged just because I'm lazy. So thank you for joining. Let's get into it. So let me just open up a couple of folders before we get into Gemini-CLI for reference later. So I'm going to cd into .gemini and launch VS Code. And everything's zoomed in already, good. And I'm also going to change into my Packet Copilot, or my Packet Buddy extension code. And we're going to take a look at the differences here. But first, let's do some packet analysis. Let's not bury the lead here. All right, so I'm going to go into this jamming folder. And here's all the captures I have. So I have a BGP capture, a single packet capture, a malicious worm, another malicious overlapping packet teardrop attack, a four packet DHCP example, and an EIGRP example. If you have packets you want to email me or something, I'm sure I could download them. We could play with them today. We can get into that later. So I'm going to launch Gemini-Y, YOLO mode. And let's just start with the capture.pcap file. So I have one extension with an update. All right, let's see. And there's an update to the CLI. Okay, so what we're going to do is we're just going to let all of this update. We're going to let this settle. And then we'll move ahead. And I'm going to check my extensions list. So Vision has an update. Extensions, update, Vision. And we're just going to let, okay, everything is updated. All right, so we're going to exit out and we're going to go back in. And we're going to do some exploration before I do a packet analysis. I want to sort of show you the lay of the land here. Control O will show you your logs, your debug console. So if there's any errors that come up, you can look into a debug console. Control Y is YOLO mode. And you can see the actual change in color, blue to pink. Now YOLO mode means go ahead and just accept any MCP calls, any shell calls, anything that needs permission from Gemini, from a user. You can just YOLO it and just say, you just go ahead and do the things. So if I do /MCP, I'm going to show you this packet buddy from packet buddy. Now this means it's from an extension, and we have 8 tools as a model context protocol. I also have /packet buddy, help and analyze. So if I want to say analyze and just get right to capture.pcap, I can do something like that. However, I like to do the natural language way. So what we're going to do is say, let's grab the phrase here. Can you give me the L2 to L4 analysis of the capture.pcap? Now what's interesting here is that I didn't have to tell it to use any specific tools. It's going to know exactly how to handle this PCAP as a CLI. See how it's picked a new session with my buddy MCP server? And it knows the first thing it needs to do is take that PCAP and make it base 64 so the MCP can use it. So it's used shell to turn that PCAP into base 64. And now it's going to upload it to the MCP. It's going to convert it to JSON. It's going to sanitize the JSON. And now it's going to index the PCAP. Now this is the retrieval augmented generation RAG process in action. It's indexed 2 chunks out of the single packet. And now we're going to analyze that PCAP with natural language on the MCP side. Not the Gemini-CLI side, the MCP side is going to finish the RAG analysis. And here's the answer from the MCP in natural language. Notice this is not a JSON payload or an XML payload or anything like that. It's a natural language in Markdown. And now Gemini-CLI can take that natural language and, can you give me your analysis based on the MCP analysis? Usually, that's weird. Usually right here, it gives me Gemini's interpretation of this. So that was a bit of a bug. That's weird. It shouldn't have said, is there anything? Here we go. Okay, so contains a single packet, one-way communication for a client on a private Wi-Fi network to a public server. Layer 2, device with the IPs. So let's try that again. I'm going to ask the same prompt here. Can you give me a layer 4 analysis of the PCAP? And let's say, can I get a markdown table of the various source and destination addresses from L2 to L4. Okay, now while it goes through that process, let's take a look at some of the code. So we're going to look at the code first. And let me crank up the view here. And there are multiple layers here, so it's kind of strap in. So from the outer layer, what we have is a Gemini MD file. Now inside of Gemini, there is a parent Gemini MD file. And I've told the parent, when asked to analyze packets, always use the Packet Buddy extension. This parent MD file will get extended with this custom specific MD file with the instructions on how to handle packets with this extension. All right? Now, the other file is a Gemini extension JSON file, and this is important. This has the name, the version, the description, the MCP servers, which is my Packet Buddy, but you're going to notice here, I handle this a bit different. I'm actually going to set up a full environment. I'm not just pointing to some Python script or some API call. I'm going to build a full environment via a bash script to host this MCP server, and my context file name to extend the parent context file is Gemini MD. We could exclude some tools like exclude shell or exclude whatever, but I don't exclude anything. Now, slash commands are just TOML files. And I actually have to work on this help a bit. Anyway, these are the slash commands. So if you want to just do a direct analysis of a packet capture, you can invoke the analyze TOML file, which will give it the instructions it needs. Now into the MCP. What you're going to see is my bash script, and the bash script installs the Python version, T-Shark, and my requirements for my virtual environment that I'm setting up. It also sets up this venv. Install all of these packages that I need to support this server code. And this server code is a fast MCP. Where we instantiate the fast MCP. We have all of our code. And then we decorate our tools like convert to JSON, sanitize JSON, index the PCAP, analyze the PCAP, describe the PCAP, and clean up from the session. Now, what is different? Let's go back to the code first. Okay, well, let's just check in on our packet. Okay, here we go. This is really cool. This is what I expected the first time. All right, based on the previous analysis, here's a summary of our findings. Right now, can you give me this analysis with a table? So here's the layer 2 information, the MAC addresses, the layer 3 information, the IP addresses, and the layer 4 information, the port numbers. And we have this nice table here from this packet. Okay, so now let's do some BGP one. This is actually really cool because BGP is sort of a CCIE topic. So we're gonna, can you explain the BGP, right? And give me any, markdown tables to support and help my understanding of the capture in addition to a verbose analysis acting like a CCIE, something like that. All right, now let's get back into the code. Okay, so I've shown you the code. Now what does this look like inside of Gemini once we've installed it? All right, so there's an extensions folder. There's the Packet Buddy, and it has everything that you've already seen, but it adds this install, and it just shows, where it got the install from and how it installed it. And it has the virtual environment here. So this has the Python and all of the included libraries that I set up for the virtual environment, all these packages, and T-Shark and Python 3.11 and stuff is all in this virtual environment. Now, let's see how this packet capture is going. I'm going to show you how to troubleshoot one. All right, so let's just say what you're going to get when you launch Gemini, if you have a problem with your extension is a 3200 error, something like that. Now, I've had this on a couple machines where their base Python environment is 3.9, and these extensions need at least 3.10. So on the user side, you're going to get an error that says like MCP failed to load, 3200 error or something, and it just doesn't load. What you can do to troubleshoot this is I'm in the Gemini folder. I'm going to go into extensions, Packet Buddy, servers, all right? And you can see that I have the virtual environment here. So from here, I can do source./packetmcp bin activate, and then I can do /packetmcp bin python 3 server.py. And what I should see is the fastMCP happy and healthy, and that it is running on stdio. Okay. If here it says I'm missing fastMCP or I'm missing something, you can manually try to do what I just did here, except instead of running it, do the pip install requirements, and it'll spew some error, probably that your Python locally is 3.9 and you need Python 3.10, something like that. So that's how you can troubleshoot one. That's a little advanced tip I didn't plan on covering. All right, now check this BGP information out. CCIE level analysis of the BGP session lifecycle. BGP capture from an engineering perspective. Capture illustrates fundamental mechanics of a BGP peering session. TCP transport to BGP state machine transitions. We see a session gracefully torn down and a new one successfully established. So the capture begins with a graceful termination of an existing session. Graceful teardown is critical because it indicates a deliberate administrator initiated action or clean shutdown rather than a network fault or protocol error. Like that insight alone, using just Wireshark through the GUI and pointing and clicking and clicking and clicking and filtering, right? It just did it, right? Some key observations. And now here's the teardown sequence. Packet 1, 2, 3, 4, timestamp, source destination, the flags, the info. 2, an establishment session. Approximately 8 seconds after the previous session concluded, a new session is established, strictly following the RFC 4271. Pretty cool. Here's the three-way handshake. It relies on port 179. We can see this right here. Opens the session. And then we have the keep alives. Final conclusion. Capture provides a textbook example of the BGP session flap, demonstrates a clean administrator-driven session followed teardown, followed by a flawless session establishment according to the RFC standards. There are no errors, retransmissions, or anomalies in this capture. Right? Any questions out there? Where's everybody coming in from? We got like 9 or 10 people watching. What do you think so far? Let me know. I'd love to hear from you, where you're from, what your thoughts are, if you have questions of your own. So let's just move on to another packet. Let's do this 4 packet DORA. Whoops. Explain the 4 packets in this capture. Make tables and such as required to help my understanding. Hey Sheridan, nice to see you. Awesome. All right, so I've sort of really covered everything in terms of, if there's any questions about the code, we can go over it. But here's the 4-step process, or the 6-step process for RAG. What I might do is add here a step to output the sanitized JSON. I've been thinking about maybe an augmentation here, like right here in this step, to just print out whatever's in this temp file and show the user the translated JSON. But if there's a lot of packets, it's going to be huge, right? So maybe the first 4 packets or something. I don't know. Or maybe I could query and say, after you reach the sanitized JSON step, can you show me the JSON? So here's the, natural language response, and then here's the, right, check this out. So break this capture down. Clear, albeit slight anomalous view of the initial phases of the DORA, DHCP DORA process. 2 distinct yet incomplete DORA cycles. We see discover and offer. So we don't actually get to the, pretty cool. Client fails to send the request after receiving an offer. So this is not actually a good DHCP example. There's actually problems in this flow. Maryland, cool. Hey, that's cool. Thanks for joining. So this DHCP example I have is actually not good. That's interesting. So then we have an EIGRP. So let's grab the EIGRP one. Whoops. Okay, so yeah, let's check the EIGRP. And then what I'm going to do is I think my capture.pcap has a public address in it. So maybe we could tie in the computer use or the other tools through Gemini-CLI to maybe look up that address and see what we can find about it. That might be fun to show you another extension example. So computer use lets it run your own browser autonomously. So I don't know. Let's see if that works. CAPTCHAs might get in the way, but we can try it. We can try it anyway. So this EIGRP had 15 packets, and we got 30 chunks indexed in the vector store. So that's, it's breaking down the packets into 30 chunks, and now we're going to get the summarized EIGRP neighbor formation and route exchange, detail the hello and update packets. There's the response from the LLM, and then here's Gemini's interpretation. Pretty cool. It's got the AS number. It's got the multicast address. It's got the K values. A reliable exchange. Pretty cool, right? Anyway, what do you think of France? That's cool. France. That's cool. So, let's try something with the capture. Can you analyze... Actually, there's 2 more. Before I get to computer use, check this one out. Watch this. Are there any security concerns or malicious traffic indications in the capture 01.pcap? Give me the tables and act like a CCIE, but also a CISO. So originally this packet was called slammer.pcap. And then I got thinking, maybe I'm actually tipping my hand and telling the LLM that it is a slammer worm packet. So I've renamed it Capture 01. And you can see I didn't mention anything about worms or specific signatures. I just said, right, is there any security concerns or malicious traffic indications in this? right? Now check this one out. I think this is really impressive. I know that there might be some security folks, not just network folks, because packet analysis is really a broad field. It goes much more beyond just network architects and engineers. Security is very interested in PCAPs, and Wireshark is a very difficult tool. It's takes a long time to become very good at Wireshark. So I thought that this would reduce the friction and maybe democratize. And this might be 80% of the way there. I'm not saying I'm replacing Pat Wireshark. You still might need to do the last 20% of your homework. Okay, let's check this out. Like it knows. It knows it's a slammer worm. Is anyone paying attention to this? Yeah, do the worm. Look at this. All right, so as requested, here's a formal analysis. From a CISO's perspective, we must assess risk and ensure compliance. From an IE's perspective, we must understand the technical underpinnings of the traffic and the impact on the network. This report combines both disciplines. The Capture 01 file, despite containing only a single packet, represents a critical security finding. Traffic is not benign. Direct indicator of an attempted network intrusion, specifically the characteristics of a SQL slammer worm. Fast spreading piece of malware that was rampant in 2003, which aligns with the capture's timestamp. Represents a direct threat, availability, and integrity of the targeted asset. Although historical, the finding serves as a stark reminder to the importance of perimeter security, patch management, and blocking unnecessary services. Right? And you can see there's the breakdown of the packet profile, right? The port number, attacked signature, absence of benign traffic. Pretty cool, right? Now, let's do the same. Similar, but for capture 02.pcap, right? I should say same. Same question. Now, again, that's it. Same question, but for capture 02. Now, capture 02 is even more complex. That was an easy one. That's got a well-known port number, and everyone knows the slammer worm. It's a 22-year-old thing. This is a teardrop attack with fragmented IPs. This is quite a sophisticated attack. And I'm very curious to see what this picks up from the teardrop. If anyone's got a packet they want to send me, like just drop it to my Gmail and I'll drop it in here. No problem at all. The smaller the better, like less than 100 or 250 packets. We could do more. It just would take longer. Okay, so here we go. Okay, so it's thrown an error. Why? Let's try it again. Hang on. That's weird. Let's try that again. Didn't convert it to JSON. I just did this yesterday. This is an intermittent bug I think I've hit. Maybe let me start a whole new session and try capture 2. Please provide the integrity. ls capture 02.pcap. All right, let's try it again. That's strange. Let's try it again. All I did was rename that file. That shouldn't have broken anything. I have done this with this file. Sorry to go silent. I'm trying to think of why that would have failed. Let's just let it do it again. So it uploads fine. Convert? No, it won't convert it. Weird. Yeah, read the error. What's the error? File integrity problems. Okay, let me just give me a second here. Let's just try one more time. I'll move on from this if this doesn't work. I'll do something different. That bothers me. I don't know why it won't convert it. Okay, new session. Convert it to base 64. Upload, convert to JSON. Sanitize the JSON and then vectorize it. Yeah, so Rishi, yes. I haven't fine-tuned any models. All the insights are from Gemini 2.5. But what I am doing is taking the packet capture, putting it into a vector store, and allowing the LLM to do a retrieval augmented generation lookup to actually get the data from the packet. So let's see what happens here. I'm really sorry that this packet's being fussy. Okay, here we go. Let's see what happens. No, it failed. It doesn't like this packet. That's unfortunate. All right, that's fine. That's fine. Let's move on to something else, which is going to be fun, and I haven't tried it yet. So what we're going to do is, can you analyze capture.pcap, and if you find any public IP addresses, can you use computer use to look up their public information using various web tools? Feel free to scroll, click, complete fields using the IP you find, and take screenshots to gather and augment the initial analysis of the packet. Feel free to use the shell to do NS lookups, who is, trace routes, anything else you can think of to go beyond just the packet buddy analysis. Something like this. All right, now check this out. Oh, hang on. Headless equals false. Meaning, don't run it behind the scenes, the browser stuff. Show me the browser stuff. Do it in headless false mode. Do it in headful mode. All right, so first, let's watch. This is going to be a lot of fun. We're going to do the PCAP analysis first. And then maybe it's going to use the shell to do NS lookups or who is or trace routes or whatever. And then it's going to use maybe the browser to do public reputation lookups or any other public tools that it can think of to analyze the public IP that it finds. That's my goal here. That's what I'm hoping happens. No PCAP uploaded. Now the whole tool's falling apart. Let's try this again. Yeah. Hey, and thanks for joining me on this Saturday. So hang on, now we're having a problem with that tool. Let's relaunch the whole thing. Try it again. And if this is a problem, then I might have to do some troubleshooting. But because I was a little curious about the Capture 02 because it normally worked. And now even Capture 01, which I did earlier in this live stream. Okay, let's see what's going on here. I hate to say it's not stable, but this is the first time I've had these kind of issues with it. Because it's worked just fine all day yesterday and the day before. I've been so busy. I've been wanting to record, and I thought instead of recording, I would just live stream to get, community feedback and stuff. See, now it's working just fine. All right, there was just a hiccup there. All right, so let's see what goes on here. Let's see. This is really exciting here. It is indexed. There we go. So the question is just list all public IPs in this capture. Maybe should have augmented that with give me an L2 to L4 analysis or something. All right, so it did find that public IP. Now let's see what goes on here. So it launched the shell all by itself. Check this out. So it did a shell who is on that IP. It did an NS lookup. It's doing a trace route. Dane, yeah. Live demos, that's right. You nailed it. Okay, so check it out. It's going to abuseip.com. Did it just beat the CAPTCHA? No, it shouldn't beat the CAPTCHA. This isn't going to work. So Gemini-CLI is specifically coded to not beat CAPTCHAs. And I was worried about the CAPTCHAs. Let's just let it do it. So it'll try a different site here. So it's going to virus total. What are some other websites it could try? Okay, so here's the thing here. Abuse IP, virus total. It's got the screenshots. Cisco website, WebEx, slightly legitimate communication. Pretty cool, right? That it tried to do that. Now that it's very early in the computer use. So Abuse IP had a CAPTCHA, and it didn't really do much on virus screenshot. If we had some other websites, some other reputation websites, let's public IP address lookups. Okay, so let's just give it some sites. Can you try and let's just feed it some sites here. And yeah, that should be good enough. Right, headless equals false. Talos. Oh, I'll do Talos too. That's a good one. Oh, shit. I didn't know it did it. It already jumped. Okay, so watch. It should punch in the IP into that address field and hit the lookup button. So it's visiting the sites. I didn't see it actually type anything into any of these, though. Did you? Hmm. Okay, well, yeah, kind of neat. I didn't see any input either. Let's try that Talos one. All right, let's try this again. Can you look up the public IP and give me a report? Just something like that. I didn't see you actually input the IP and click. Should work. I've seen this do it. I've seen this work. No, you didn't do anything. I've seen it like look up Wikipedia pages and stuff like that. Talos should work. I don't know why, unless Talos detects that it's a bot and just is preventing it. Hmm. Can you look up the public IP in the capture.pcap against? Go into the text box and input the IP and click the button and give me a summary analysis. Stage fright. Yeah, exactly. I mean, if this doesn't work, I might just do an example of a Wikipedia lookup or something just to show you this computer use does actually search and click and scroll. And I've made videos about it. It is being stubborn today, and I don't know why. It should actually go right into that Talos thing and type the IP and click the button. I've seen it do it. Anyway, not Talos, but I've seen it do it on Wikipedia, for example. Now it's specifically programmed not to defeat captchas for public safety. Okay, so here we go. Initialize browser. I didn't say headless, did I? I didn't say headless. So well, let's see. It is trying to type in the IP, right? So There's the IP, and it pressed enter true. Let's try headless equals false. Okay, go into the box. You can do it. No. That's okay. That's okay. That's okay. Um, so put the IP in, right? No? No, it's 170. All right. I thought I saw this change here. I wanted to actually type it in this. That sucks. All right, well, that's really unfortunate because I was hoping this would be a pretty cool demonstration of this capability. See, it knows the IP lookup button. So this did work. Can I look at this picture just to prove it? Yeah, see, it doesn't. I don't know. I don't know that it's working. Um, hmm. Hmm. Can you look up the OSI model on Wikipedia headless equals false? Now, this is probably not going to work either right now, given my luck. Yeah, see, it went right to the page. Can you search for network computer networking on Wikipedia? Headless equals false. No, it's not working. Well, anyhow, I'm sort of drifting from the original idea of the packet analysis here. Let me go back to chatting mode. Thanks for joining me for this little bit of time on Saturday morning. The code is there. Just install the extension and show me what you're doing with it. Show me your packet analysis. Show me your conversations. Put the videos up. Tag me. Send them to me. I'd love to share them. I think this is really cool, right? Just chatting and asking natural language questions and prompts against PCAPs. Very frictionless. You just talk to the thing, right? So thanks, everyone, and I'll talk to you next from Poland. I'm off to Warsaw next week, so I'll be checking in from Poland.